Hi, this is Palomo. In today's video, we will graph triangles and their altitudes, and then we'll find the point of concurrency of the altitudes to get the orthocenter. The concepts that we will use in today's video include graphing triangles, graphing altitudes, finding slopes, working with the slopes of perpendicular lines, and finding an orthocenter. That's a lot of topics. We're using Palomo for the lesson today because graphing orthocenters is cool. So, we want to find the orthocenter of a triangle with the vertices of the triangle at 2, 3, 7, 8, and 8, 3. So let's go on over and plot those points. R, 2, 3. S, 7, 8. I'm just going to label it S. And T. Eight, 3. So I've got my triangle. It's always good to do these orthocenter problems on graph paper because it's better to be precise and it gets a little bit messy. So graph paper is always very helpful. Okay, so now we've got this triangle and we know that we want to find the orthocenter by finding the point of concurrency of the altitudes. Now we know that the altitude is drawn from the opposite vertex to the perpendicular line that contains the segment. It's perpendicular to a line that contains the segment. So sometimes we have to extend these lines or segments of the triangle to find that perpendicular part, but let's see if we need to do that for this one. Now what I do is I look for any horizontal or vertical lines. In this triangle, we have a horizontal line RT. Now we know the line that's perpendicular to RT is a vertical line and it goes to the opposite vertex. So the first and the easiest altitude that I'm going to draw is really the height of my triangle, and that's the first altitude. Well, that's the easy altitude. So we know that the altitude is the perpendicular segment from a vertex to the line containing the opposite side. Now in this case, the altitude is going to the opposite side, but sometimes we have to extend the lines or the segments of the triangle to get that perpendicular distance. So now for these other two sides of the triangle, the altitudes aren't as straightforward, and we want to take the altitude is the line from a vertex to the perpendicular line containing the segment of the opposite side. So if we're going to go from the vertex R, we have to hit ST in a perpendicular fashion. Now we can't just draw that and guess what's perpendicular, but we sure can use the slopes of lines and the slopes of perpendicular lines to find that altitude. So the first thing we're going to do is find the slope of ST using rise over run. And then over. 5, 1. So the slope of ST is 1, 2, 3, 4, down 5 over 1, which is a negative 5 over 1. So what is the slope of a perpendicular line to ST? Because if we have ST, the vertex that is opposite ST is R. So we want to draw a line from R to ST, but we want it to be perpendicular to ST. So if that altitude is perpendicular to ST, we need the slope of the perpendicular segment to negative 5 over 1. And we know that that is the opposite reciprocal. Flip it, change the sign. So we've got the perpendicular slope to be 1 over 5. So step 1 is getting the slope of one of the sides of the triangle, finding the perpendicular slope to that slope, and then starting at our opposite vertex. So I was talking about the slope of ST. I would like to start at the opposite vertex. So I'm going to start at R, and I'm going to use my rise over run of my perpendicular slope to ST, and I'm going to get 1, up 1 over 5. Rise 1, 1, 2, 3, 4, 5. Ooh, it looks like it's already hitting that altitude. I'm going to do it one more time. Up 1, 1, 2, 3, 4, 5. So I can see that I'm getting this altitude. I'm lining it up. And I'm going to do a dashed line, which is the altitude from R to ST. And look, we already have found the intersection of two altitudes, which is our orthocenter. But let's do the third one just to make sure we did it right. We want to make sure we've got that third one right. So I did the altitude from S to RT. I did the altitude from R to ST. And now I would like to go and find what is the slope of RS, and then find the slope of the perpendicular line to RS and start at its opposite vertex. It's the same process. So let's do that. Let's find the slope of RS. I'm just going to write it up here. Slope of RS equals 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 over 5. So we've got 5 over 5, which is 1. The slope of RS is 1. Now this is a great exercise because now we know that the slope of a perpendicular line to RS is 1 over 1 flipped is still 1 over 1. Change the sign and we've got negative 1. The slope of the perpendicular line to RS is a negative 1. Now I'm talking about the segment RS, so I'm going to start with the opposite vertex T, and I'm going to use a slope of negative 1. So I'm going to go down 1 over 1. I could continue, or I could go up 1 and over 1 in the negative direction, and look at what is happening. I am getting the altitude to intersect, or also be the point of concurrency of all those three altitudes, gets us the orthocenter. Great. That was a pretty quick problem, except we have to finish it off because we want the coordinates of the orthocenter. So I'm just going to write it right on over here. Orthocenter, orthocenter. And this is where you have to be really careful because our coordinate system is here and we start at 0, 0. If they want the coordinates of the orthocenter, remember you have to find the coordinates and with reference to the origin. So if we start at the origin and we want the coordinates of the orthocenter, that is 7, 4. Our orthocenter is at 7, 4, and that was found by graphing the point of concurrency of the altitudes. Now you try. Can you do it?
Thanks for watching. Peace out.